Good morning, everyone. Once again, it's Aamir sir here in front of you with the fifth lecture of chapter solution. So, in fourth lecture, where we have ended, we'll start from there only. So, let's begin with the factors affecting solubility of gas in liquids. So, we have seen that O2 and 2 are much soluble in ethyl alcohol than in water. So, I have given you the reason that O2 and N2 are non-polar molecule and ethyl alcohol is also non-polar. So non-polar dissolve where in non-polar, but water is polar, therefore oxygen and nitrogen are very less soluble to water than in water at same temperature and pressure. While on other hand H2S and NH3 are polar molecule are more soluble in water, that is also polar, than in C2H5OH ethyl alcohol. This is due to the chemical similarity between the gas and solvent. So why this is happening? Because of chemical similarity. Why? Which type of chemical similarity? That polar dissolve polar, non-polar dissolve non-polar. So that is the chemical similarity. Now coming to the second factor which affect the solubility of gas in liquid is the effect of temperature. So the solubility of gas decreases with increase in temperature. So general concept is this only, that with increase in temperature solubility of gas decreases because gases have kinetic energy. If you increase the temperature, they attain more kinetic energy and they will not dissolve in the liquid. So therefore the solubility of gas decreases in liquid with increase in temperature. Dissolution of gas in liquid is exothermic process. So dissolution of gas in liquid is exothermic process. So heat is released. So dissolution means dissolving of gas in liquid. We have seen the term dissolution. So gas plus solvent when mixed, so it gives the solution plus heat is also released. So if the heat is released, if you will increase the temperature, then the solubility will decrease. Applying Le Chatelier's principle, it is evident that increase of temperature would shift equilibrium in backward direction. So if the process is exothermic and you are giving the temperature, so the reaction will get reversed. Means instead of formation of solution product, the gas and solvent reactants will be produced. So therefore it is said that the reaction will proceed in backward direction, that is the solubility decreases. Solubility of gas in solvent decreases. Exception, solubility of some sparingly soluble gases. So few exceptions are also there which is given here, that solubility of some sparingly soluble, sparingly means less soluble gases like H2, inert gases like helium, neon, argon, krypton increases slightly with increase of temperature in non-aqueous solvent like hydrocarbons, alcohol and acetone. So it is seen that is the exceptional case that solubility of some of the gases, sparingly soluble gases, increases slightly with increase in temperature, where not in water but in non-aqueous solvent like alcohol and acetone and some hydrocarbons. So just keep in mind the exceptional case. Now we are proceeding towards the third effect. So that is the effect of pressure. That effect is also called Henry's law, as Henry has given it. Most important factor. So increase in pressure leads to increase in solubility. So keep in mind that increase in pressure leads to increase in solubility for solution of gas in liquid. So with increase in pressure, the solubility of gases increases in liquid. So just consider a system. A system is given for a solution of gas in liquid. So we have taken a weight. Let the weight of that, the first one be W1 and second one be W2. Solution phase is shown here. So what happened? So when we compress it, so by if the container is being compressed by applying the weight, what will happen? Gaseous phase of pressure and temperature, solution phase. So below one is solution phase and above one is gaseous phase. So we are seeing that if there is less weight, the gaseous phase and the solution solvent phase are not mixing, they are far little bit apart. But when the weight is included, W2 is included, they are being shifted to the bottom. It means they are getting more soluble to the liquid solution, liquid solvent. That gases are getting soluble in the liquid solvent. So demonstrating effect of pressure on solubility of gas in a liquid. So pressure is being built up by these weights. So these weights are building the pressure on the solution. So when the weight is being applied, pressure is being put on to the solution, more and more solute is getting dissolved in the solvent. So that is demonstrating the effect of pressure on solubility of gas in liquid. The lower part is solution and the upper part is gases which are at pressure and temperature, at certain pressure and temperature. Suppose system is in dynamic equilibrium, means the rate of dissolution is equals to rate of evaporation. So if it is in dynamic equilibrium, means some of the reactant, some of the solute is mixing with the solvent and some of the solvent is again changing to the solute. So if that is the condition, dynamic words meaning is this only, then the two opposite rates becomes equal. Rate of dissolution will get equals to rate of evaporation. The amount of gas which is getting dissolved, that is called dissolution, and the amount of gas which is getting evaporated from the solution, that is called evaporation. So when gas gets compressed to a smaller volume, number of gaseous particle per unit volume increases. So if the gases is getting compressed to a smaller volume, number of gaseous particle per unit volume increases, resulting in number of gaseous particle is striking the surface of solution and hence entering into it. So what we see, when the pressure is increased, most of the solute gaseous molecule strike the solvent surface and they get enter into it. The same thing is said, surface of solution and hence entering into it. into it. Thus, now equilibrium of gases above solution, there comes the increase. Equilibrium above solution, the solubility increases. So by this way, the solubility of gas in liquid increases. So what the Henry said, what was its law? It can be asked in 1 or 2 marks question, what was Henry's law? So Henry established the relationship between the pressure and the amount of gas dissolved. So he said that the quantitatively effect of pressure on solubility of gas in liquid was studied by Henry when in 1803, called Henry's law. What he has said, the mass of gas dissolved in a given volume of liquid at constant temperature is directly proportional to the pressure of gas present in equilibrium with the liquid. So he has said that mass of gas dissolved, the amount of mass of gas dissolved in volume of liquid at constant temperature is directly proportional to what? So the mass of gas dissolved will be directly proportional to the pressure of gas present in equilibrium with the liquid. So how much pressure we are applying, the same amount of gas will get dissolved in the solution. So mathematically it is said that m proportional to p. So m is the amount of mass of gas which get dissolved by applying the pressure, m directly proportional to p. So remove the proportionality, we used to have constant, so we have m equals to kh into p. So where m is mass of gas dissolved in unit volume of solvent, so m is the mass of gas dissolved in the solvent. What is p? P is the pressure of gas in equilibrium with the solvent. What is kh? So constant, called Henry's laws constant or sometime called Henry's constant, depends on characteristics of gas and solvent and temperature. So the Henry's constant depends on the characteristics of gas. What is the characteristics of gas? What type of solvent is present and what is the temperature? So Kh depends on these three factors. Further, it is said that the solubility of gas in a liquid at a particular temperature is directly proportional to the pressure of gas in equilibrium with the liquid at that temperature. So solubility of gas in a liquid at certain particular temperature is proportional to the pressure of gas. How much pressure is being applied in equilibrium with liquid at that temperature. So expression of solubility in terms of mole fraction. So what will be the expression of solubility in terms of mole fraction? If it is gases, so we consider it in terms of moles instead of mass. So in terms of mole fraction of gas in the solution for gas A, Henry's law that partial pressure of A is equals to Kh into Xa. Xa stands for mole fraction of A. So the pressure of A is equals to kH into mole fraction of A, where XA is the mole fraction of gas in solution. What is PA? So PA is partial pressure of gas above solution. Again, PA is particular pressure of gas above solution. What is KH? KH is Henry's constant, whose value depends upon nature of gas, nature of solvent, and temperature, which we have seen above. For example, we have the example solubility of nitrogen in water at 298 Kelvin and partial pressure of 0.78 atm is 5.3 in 10 power minus 3 mole per liter. If partial pressure is doubled to 1.56 atm, solubility of nitrogen in water is doubled and it becomes 1.06 in 10 power minus 2 mole per liter. So what we are seeing, that if the pressure gets doubled, the amount of gas soluble in water also increases. So the pressure gets doubled, the amount of gas solubility of nitrogen also gets doubled. So we have the final formula that Pa is directly proportional to Xa, that is the mole fraction of A, or Pa is equals to Kh into Xa, means the pressure of gas A, the amount of gas which get dissolved, the pressure applied is equals to Kh into mole fraction of A. So that is the final equation for it. Then we have the partial pressure of gas in vapor phase is directly proportional to mole fraction of a gas in the solution, which we have seen. So partial pressure P is proportional to X. KH is atm. What will the unit? KH is atm or bar. It can be a kilo. It can be in kilobar also. No, it is showing with the graph. Plot of mole fraction in solution versus equilibrium pressure. So pressure and mole fraction curve is plotted. What we are seeing a straight line. So when the pressure is increased, mole fraction of HCl in solution in cyclohexane is also increasing. So with the increase in pressure of equilibrium pressure of HCl gas, what we see that the mole fraction of HCl in the solution in cyclohexane also increases. So we get a straight line. So different gases have different value of KH at same temperature and in the same solvent. Values of Henry's constant for some of the gases is given, so you can get it from the book also, that is given some of the values of Henry's constant over here. Now we have following conclusion can be drawn from Henry's law. So what are the conclusion? So first conclusion is Henry's constant Kh is a function of nature of gas. So it depends on the nature of gas, Henry's constant. Second, greater the value of Henry's constant Kh, lower is the solubility of gas at same partial pressure. So keep in mind that Kh is inversely proportional to solubility. So if the Kh value is more, the solubility of gas is less. So they are inversely proportional. So if the value of Kh is more, just keep in mind that its solubility will be less. Third point, the value of Kh increases with increase in temperature. So with increase of temperature. So value of Kh increases with increase of temperature implies that solubility decreases with increase of temperature at same pressure. So when the temperature is applied, so Kh is directly proportional to temperature, so solubility of gas will decrease because it is inversely proportional to it or to the pressure with increase of temperature at same pressure. So gas could not go for compound formation with solvent on dissolution. So that is the limitation, that gas could not go for compound formation with solvent on dissolution. So compound is not formed. So some few notes is given that Henry's law is not applicable in case of dissolution of ammonia in water. So Henry's law is not applicable to dissolution of ammonia in water. Why? Because it undergoes compound formation. So when ammonia react with water, it leads to the formation of compound. So in that case, Henry's law is not applicable. It will not be applied. if the compound is formed, and also in dissolution of HCl in water. So when HCl is dissolved in water, then the same things happens because it undergo dissociation after dissolution. So HCl goes to dissociation when it get dissolved or dissolution done. So therefore, HCl and NH3 when dissolved in water, so the Henry's law formula will not be applicable in that case. Now few applications of Henry's law is given. Just keep in mind, in production of carbonated beverages, to increase the solubility of carbon dioxide in soft drinks, we know that in soft drinks compressed carbon dioxide is there, soda water, beer, in all bottles are sealed under high pressure. When bottle is opened to air, partial pressure of CO2 above solution decreases and CO2 bubbles out. So why CO2 bubbles out when the soda water bottle is opened? So that is the reason. Henry's law's application is there, that solubility of gas, carbon dioxide gas decreases when the pressure, because they are pressed to high pressure. So when the bottle is opened, the pressure get released and the solubility of gas, carbon dioxide gas decreases and gases bubbles out. In deep sea diving, on scuba divers, according to Henry's law, solubility of gas increases with pressure. Thus, both nitrogen and oxygen will dissolve considerably in blood and other body fluids. So what happens when the pressure is increased? Nitrogen and oxygen both gets dissolved to a large extent in blood other than body fluid. So therefore what happens when they get dissolved? Oxygen is used for metabolism, but due to high partial pressure and greater solubility, nitrogen will remain dissolved and will form bubbles when divers comes to atmospheric pressure. So what happens if there is more nitrogen? So they forms the bubbles. These bubbles affect nerve impulse and give rise to disease called bends or decompression. So if there is more amount of nitrogen in the sea with increase in pressure, then that leads to a disease called bends or decompression. So decompression sickness can be arises. So to what we have to be the combination in the cylinder which we used to have at our back. To avoid it, the cylinder used by divers are filled with air diluted with helium. What is the percentage of helium? It should be 11.7% helium. What should be the nitrogen percent? 56.2%. And what about the percentage of oxygen? It should be 32.1%. So whenever the scuba divers used to have the scuba diving at the bottom of sea, so they used to have the oxygen cylinder with them, and that oxygen cylinder used to carry helium 11.7%, nitrogen 56.2%, and oxygen 32.1% to avoid these types of problem. Next is in the functioning of lungs. When air enters lung, partial pressure of oxygen is high. This oxygen combines with hemoglobin to form oxyhemoglobin. Partial pressure of oxygen in tissue is low, hence oxygen is released from oxyhemoglobin is utilized for functioning of cells. So in cell functioning also, the application is that depends on the pressure of oxygen. From higher concentration it goes to lower concentration cells. So by that way oxygen gets transferred to the cell. Next is for climbing or people living in high altitude. Now we are talking about the mountains, mountain climbers. A high altitude partial pressure of oxygen is less than at ground. So at higher altitude the pressure, atmospheric pressure gets decreased, and therefore there is less oxygen to breathe at ground level than at ground level. As a result, there is low concentration of oxygen in blood and tissue of people living at high altitude. They feel weak and are unable to think properly. A disease called anoxia. Anoxia is a disease which results because of availability of less oxygen at higher altitude. Why it is less? Because atmospheric pressure decreases, the solubility of gases in the atmosphere also decreases. Now we have the question based on it. So we are going to see the first question of Henry's law by using the formula Pa equals to EH into X. So first question is, if nitrogen gas is bubbled through a water at 293 Kelvin, how many millimoles of nitrogen gas would dissolve in 1 liter of water if partial pressure exerted by nitrogen is this, given Henry's constant for nitrogen at 298 Kelvin is this much. So you have to get the millimoles of nitrogen gas which dissolve in 1 liter of solution. We need to get the moles. So by knowing the formula partial the Henry's law formula, what we have that Pa is equals to Kh into Xa. What is Pa? Partial pressure of gas A. Kh is Henry's constant and Xa is mole fraction of gas A. So what we have, we know the partial pressure of nitrogen is given in question 0.987 bar. Kh is given 76.48 kilobar. Number of mole fraction is not known for nitrogen and number of moles is also not known for nitrogen. So we have to get this one. So by applying the formula we can get the mole fraction. From this formula we can get the Xa. Here X is N2. So P is known, KH is known. So just apply the formula, we'll get 1.29 10 power minus 5. Now we have to get the number of moles. So for getting the number of moles, we have the mole fraction, we can apply the formula. If n moles of nitrogen are present in 1 liter of water, then what will be the number of moles of water? So for water, if it is 1 liter, so we can take 1000 ml. Mass of water be 1000 ml and molecular mass of water be 18. So 1000 by 18. We get what? How much number of moles? So it will be number of given mass by molecular mass 55.5 mole. Now apply on the mole fraction of nitrogen equals to number of moles of nitrogen divided by number of moles of nitrogen plus number of moles of water. So we have number of moles of water 55.5. Mole fraction of nitrogen we have calculated, that is 1.29 10 power minus 5. Just apply it. For very dilute solution, keep in mind for very dilute solution we can neglect the 1n number of moles of nitrogen. So we just go with x n2 equals to n by 55.5. As n is very small, then 55.5 value. What in water the amount of nitrogen is very less. So now we have the formula n by 55.5 equals to 1.29 10 power minus 5. Just apply. We have got the number of moles for millimole. Just divide it with 1000, will get finally the 0.716 will be the millimoles. Next question is from the NCERT, question number 2.6. H2S, a toxic gas with rotten gas smell, is used for qualitative analysis if solubility of H2S in water at STP is given. Solubility is given. Calculate Henry's constant. So they are asking for the KH. Again, just apply the formula. At STP we know the temperature and pressure. So pH pressure of partial pressure of H2S equals to KH into mole fraction of H2S. So solubility is given how much? 0.195 m. M stands for molality. Molality means mole per kg. So it means we have got the mole of H2S. So mole is 0.195 mole in 1 kg of solvent, that is water. Now mole per kg means 1 kg of solvent. So 1 kg means 1000 gram. Again we'll get the number of moles for water 1000 by 18 55.55 mole. Now we can have the formula. Mole fraction of H2S x is equals to number of moles of H2S 0.195 divided by total number of moles. Applied, we get the mole fraction of H2S, that is 0.0035. Now we have to get the Henry's constant. As at STP, pressure at STP, we can use 0.987 bar. We can use 0.987 bar. The temperature, now apply the formula of Henry's law. pH2S equals to KH into X H2S. We have to get the KH. Henry's constant, pressure of H2, partial pressure of H2S is given, known. We'll use 0.987 bar and mole fraction of H2S we have calculated here 0.0035. We'll get finally 282 bar. Now next question of NCERT, that is question number 7. Henry's law constant for carbon dioxide in water is 1.67 10 power 8 Pascal at 298 Kelvin. Calculate quantity of carbon dioxide in 500 ml of soda water when packed under 2.5 atm carbon dioxide pressure at 298 Kelvin. So Henry's constant is given. Quantity of carbon dioxide in 500 ml of CO2 is asked. Quantity means you just go with the number of moles when packed pressure is given. So KH is given, pressure is given in Pascal, applies Henry's law, partial pressure of CO2, KH into X CO2. So mole fraction, we have got the KH, we have got the PCO2 value, we'll get the mole fraction of CO2. So finally, by solving it, we get 1.5 in 7 into 10 power minus 3. Now, mole fraction we have got. Now calculate the mole fraction for carbon dioxide and water. So we have the formula for mole fraction, number of moles of carbon dioxide by number of moles of water plus number of moles of carbon dioxide. We can neglect one of the NCO2. If the solution is to dilute NCO2 by NH2O, we have 1.57 517 10 power minus 3. But in question it is asked for 500 ml of sodium soda water. So what we'll do, we'll change it into gram. So for 500 ml of soda water, water present will be 500 equals to 500 gram. So 500 divided by 18. So it gives the number of moles of water which we will utilize here. So 500 by 18, it gives 27.78 moles. Utilize it now. Now we have NCO2, you can apply here. NCO2 by NH2O 1.5 117 power minus 3. NCO2 we have to calculate, NH2O is given, just apply it, you will get the number of moles of carbon dioxide. So finally by this way we have got the number of moles. If you want to convert it into mass, you can apply the number of moles formula. Given mass by molecular mass n equals to given mass by molecular mass, you can get the number of moles is given, molecular mass is given. So with the help of which we can get the mass, that is 1.854 gram. So till here we have just solved the numericals. So in the next topic we'll just go with the vapor pressure of liquid solution, and very important topic, that is the Raoult's law. So before going to the last topic, just see the vapor pressure and its definition. So vapor pressure, liquid solution are solution in which solvent is liquid and solute can be gas, liquid or solid. So whom we call liquid solution, where solvent is liquid and solute can be anything. What is vapor pressure? So vapor pressure of a liquid is the pressure exerted by the vapors in equilibrium with the liquid solution at a particular temperature. So what is the vapor pressure? So vapor pressure of the liquid is the pressure exerted by the vapors in equilibrium with the liquid solution at a particular temperature. Last para for today, vapor pressure of liquid solution. So we have to see two types of solution, liquid solution or solid liquid solution. So first we'll go Raoult's law with liquid solution, that is also called Raoult's law for volatile solute. Raoult's law for volatile solute. For solution of liquid in liquid, means both solute and solvent will be liquid. For solution of liquid in liquid, both component of solution are volatile. Volatile means they can mix. So each will form vapor above solution. So both solute when gets evaporated, solvent when gets evaporated, they forms the vapor above solution. So when equilibrium is reached, each component, means solute or solvent, will exert a vapor pressure called its partial pressure, pressure exerted by single liquid or gas, so either solute or solvent, partial pressure, whose value depends upon mole fraction of component in solution. So how much vapor pressure will be exerted? So the value of partial vapor pressure depends on the mole fraction, how much moles of that particular gas is taken, mole fraction of component in solution and vapor pressure of component in pure state. So what is the vapor pressure of component in its pure state or when it is mixed in solution? So we'll see in next class the Raoult's law and its application.